Yeah? All right. Hello. Welcome. I'm Brad Green. I'm an engineering director at Google, and I've come to talk about Angular 2 and kind of from a strategic direction about how some changes we've made in the platform I think make it really easy for product organizations to deliver much easier and much faster with one skill set and one application platform. Before I get too much into it, I should really acknowledge a lot of you here who are already part of the Angular community, so thank you for being along this journey with us. And if you've been following our story, last October, when we had our last big show, we were really excited that we had over 1.1 million developers who are part of this community with us. When we moved to now, and we take a look again at how many developers we think we have, we've had this nice bump. About 200,000 people have come on board. And this is really nice. And I think a lot of it is because in Angular 1.5, we have some much nicer APIs for building components, a lot like what we're heading towards in Angular 2. And I'm maybe even a little happier with the growth here. So in Angular 2, we are just in beta, but we already have over 330,000 developers using this for their daily production. I'll talk a little bit more about who's doing it. But you can track our progress. We're kind of in the chute for final. We're not too far away. And we wanted to let you be able to track along. So if you go to GitHub, the Angular/Angular repo, and I'll have links at the end for all of my references. But you can track along at how we're doing towards final. Not too far away. Even though we're only in beta now, we have a number of folks who have already deployed on Angular 2. Internally at Google, we've had the Fiber team deploy, and a bunch of others have gotten started. But one of the biggest one, actually the place where we make all our money, has built on Angular 2 and is now starting to have previews of their application. So the next version of AdWords, the base of Google's financial success, now on Angular 2. And we're really excited to work with them. I've got some more stories to tell about them in part of this presentation. Other folks externally are doing this. We've been also working with folks like the Weather Channel and Weather Underground, where they're building on Angular 2 with Drupal on the back end. And they've actually started to blog about their experiences and share how they're becoming successful on Angular 2 with you. And as I walked on stage, I saw a tweet where apparently NPR had just launched their NPR One service on Angular 2. So even though we're in beta, people are already able to deploy. So back to the strategy and why I think this can be a helpful part of your internal company approach. We got popular in Angular for developing for the web, and that's still our core. We love the web platform. And at the same time, though, developers usually have the need to go to a bunch of different places. And one of the more interesting places that's come back in popularity is this space for mobile web apps, where people surf to your website and have interactions. And what we're finding is that you can build a native app for the App Store, but it's super hard to get people to install your app. That install friction doesn't exist on the web. And this is why a lot of us have become web developers. It's so easy to get people to come and do stuff with us. But if you are successful, you may also want a native web app, and we'd like to support you there. And if you're someone who has something across all of the devices, Slack might be an example, you probably also want a desktop version of what you're building. And this is great, but the problem is you probably have different development teams with different skill sets, different libraries for approaching all of these pieces. If you happen to be in the Angular camp already, I think we can give you a big leg up on developing for these different devices. And have a single platform that you can develop against with different rendering models, with different back-end service connections that allow you to deliver all of these places, and I'll talk about it. And so the web platform is actually building some really tremendous pieces for us to build real-world applications now. But there's a ton of work to get them to work together, and I think this is where Angular can help, by being that glue, no subtle metaphor. And so this is our task, is how do we integrate all the things and make it smooth? And like, if anybody is trying to set up a modern web application with Gulp and some kind of transpiler like Babel or TypeScript and Sass, there's like a good day and a half of me trying to set stuff up. In addition to that, integrating all of these services is no easy thing. And so what we want to do, from the core in Angular, we're developing a base set of things you can count on all of these platforms. And so like in Angular 1, if you're familiar with it, we have a change detection mechanism which makes it easy for me to organize my code and its dependencies. We're working on a new standard called zones. And if you haven't followed us in this, so zones is a way you can manage virtual machine turns and figure out when you should render stuff. We're using it internally on Angular. Many other frameworks are interested in using this with us as well. And as part of the TC39 JavaScript standard, we're already at stage 0, which means the committee agrees this is a good thing for us to work on and solve. On top of this, we're building a compilation service so we can have these declarative HTML templates, that we have change detection that runs incredibly fast, and in Angular 2, it's about 10 times faster than Angular 1. And a rendering model that's actually flexible where we can plug in different renderers. We started with a DOM, but we'll talk about how we can find other spaces to render into. On top of this, we've got a component model, and we're actually delivering a suite of components in the Google Material Design look and feel. But we're also, at the base of it, building a toolkit. So if you want to develop other components of your own, you can use that. You can use our idioms and a bunch of the tools to build things that have a completely different look and feel. We are investing a lot in mobile. I'll get more into that in a minute. And then to make that initial view fast and to be able to handle SEO on the web, we're doing server-side pre-rendering so that you can actually just generate HTML and CSS for that initial web view and be able to render that very quickly. So that you folks as developers have a great time, we're also investing a lot, some of it ourselves and some of it with partners, in this whole tool chain. We've got a command line interface, Angular CLI, that really reduces the setup costs. That takes you all the way through, I want a new Angular application with all of the dependencies wired up, through setting up my continuous integration, running my tests, and finally deploying. And then we really want to help people who are already on Angular 1. And this is where this tool called ng Upgrade comes into play, which allows you to seamlessly mix in Angular 2 components and services into an existing Angular 1 application. And then there's some parts of the stack we're actually building that work in both Angular 1 and Angular 2. We've already delivered the router, which you can already use in Angular 1. This is called the component router, a replacement for our simplistic router we used to have. A much upgraded animation suite, and I18N, so if you're delivering to a global audience, you can do that. But I want to focus a little bit on this IntelliSense thing, because it's kind of how I get to be here. I'm from Google, you know. And we've been partnering with the TypeScript team for quite a while, and we've actually built all of Angular 2 on TypeScript now, and we're huge fans. Like the amount of IDE help in refactoring and clicking through to source and just understanding my source code is tremendously greater in a world of TypeScript where I can incrementally add types as I want to than it was before. We're now going to the next level with them, and we're working on IntelliSense within our templates. What you see here is a demo of actually getting type information in the Angular templates that refers to the bits. And so we can give you feedback on, you know, name completion and am I typing something that will actually not run before I ever get to the browser. So we're excited about this. We should have something in your hands in a couple months. Next part of our strategy, if we're delivering to the web and the mobile web, we know that we have to be very fast and very small. And so the way that we're doing this is already in Angular 2, we're dramatically faster than Angular 1 in our rendering capabilities. Where for the first initial render, we have this new technique we're calling ultra-fast change detection, where we make all of the code in Angular so that it can be inlined by the virtual machines, so that it can run at maximum speed. And you can see it like in virtual machine profiling, it runs between 40 and 50 times faster, depending on the scenario, than it does otherwise without this. Overall, you know, change detection is only part of it. Overall, Angular 2 runs out of the box 2.5 times faster than Angular 1. And if we've ever seen a view before, if we're trying to re-render a view that the user's already been to, that's about 4.2 times faster. But this kind of bothered us, and it actually bothered one of our internal partners, the AdWords team. They said, okay, it's fast, but really we would like it to be faster, please. And so we've been experimenting with a bunch of different rendering techniques on how could we go faster. And we really wanted to solve the difference between these two, and could we just always be fast? So our new goal is that across the board, we're about 5 times faster. And we're about to have this to show. We've got some good benchmarks that lead us to believe we're close. The way we're doing this is through code generation. And so what you get is our compiler, our change detection, renderer, dependency injection. These all disappear. These are not something that you have to ship to the user. You will use them in dev mode, so you don't have to go through the compilation step. But when we ship the thing, we actually get to drop the framework away. So it's much, much faster on the Bootstrap, on a cold browser start, where the VM has never seen your code before. A lot faster. It becomes much smaller because you don't have to pay for these things. You actually only pay as you go. And our goal is that it's just obviously fast, and it's what you would have gotten if you had handwritten your application without a framework helping. But yet you get all of the lift from the framework. All right. So I mentioned a little bit about this, but there's this new term for mobile web apps that we're calling progressive. And progressive in a sense that what a user would do is they'll surf to your site, and they go through this kind of auto-install process that they don't have to do anything for. But your code gets cached, and so if they ever come back to your site, it will be very fast. They will also get this sort of install to home screen service so that they could have a nice way to click in and get back to your application and make it feel like it becomes more app-like the more they use it. Now, behind the scenes, the way this works is there's this facility called service workers. And service workers do a couple things for us. One, they can cache our code and data so that it can sit there on the user's phone. And they can also update this data without the user ever having to browse back to your site. So they can always have fresh code and data, latest version of your app, just like I would experience with a native mobile app. And you can do push notifications and nice things like this. And it works with intermittent or non-existent networks. So you can be offline and still have a successful web app experience now. This is just one of the features that all the browser manufacturers are collaborating on to bring these progressive web apps to us. They'll work on the desktop too, by the way. Now, things we're doing in Angular to help even make this better. Number one, make the initial load much faster. And number two, on making it more responsive. For initial load, I kind of mentioned that we have this server-side rendering story called Angular Universal. And for responsiveness, we want to take advantage of web workers, the ability to have another thread or use another processor core on your device. For Angular Universal, the way this works is Angular is now decoupled from the DOM renderer. Not true in Angular 1. We couldn't do this in Angular 1. But we have it so that we can actually replace the renderer with something that's not a browser. And so what we do is when the user makes a request, we actually render everything, combine the template with your data, running your business logic, and just ship back HTML and CSS, which is incredibly small and renders very, very fast without any JavaScript involved. We do ship a tiny JavaScript library, or it's optional, you can, so that if the user clicks or scrolls or does things that you want to capture those events, that will then get replayed to your app once it becomes live. And so while they're viewing that initial content, we actually push down your app, and it becomes live eventually. And this works well. So some benefits, or some places that this runs right now. Right now it runs in Node.js. We've demoed this for quite a while. Last fall, Steve Sanderson demoed this running as part of .NET. We've been working with the Drupal team about making this run on PHP with Twig templates. And then with some Java folks, we want to make this run from there. And so this is the nice thing about having a decoupled renderer and also a decoupled templating system. We can now run in many, many backend environments and integrate very well, depending on what code you're writing. If you're working on Ruby or some other language you'd like us to integrate with, maybe this would be a fun thing for us to collaborate on. Now, on responsiveness, I said, hey, web workers is going to be the path here. And web workers have been around for a long time, but pretty much nobody uses them because it's super hard. And it's this nice facility, but in JavaScript, you probably know that it's a single-threaded environment. We pretend that it's multi-threaded because we have this event-based model, but really everything runs in one thread. And if I'm doing garbage collection or heavy data processing, things will slow down, scrolling will become jumpy. It's not a nice experience. And so in Angular 2, just by changing the way you bootstrap your code, you can actually move all of your code and most of Angular into a web worker off the main UI thread and have a much smoother experience. I have a demo of this. Here's this benchmark. You may have seen it or maybe not. It's a way to compare frameworks. It's called DBMon. And there's a whole bunch of framework examples in it. We kind of don't like it. Actually, Angular performs very well in this, so we kind of do like it. But we don't like it because it's not actually a true test of framework performance, because there's a lot of work that's going on in generating the data that's driving the frameworks. It is a really good example of showing how much web workers can help. And so let's go take a look. So I'm going to pull up just Angular 2 beta, and I'll blow it up so you can see the frame rate at the bottom. So we're going something like 70 to 80 frames per second, which is awesome. But let's run this now inside a web worker. And so we've just offloaded all of that heavy lifting into another worker thread, and we were getting like up to 160, down 120, but maybe about twice the speed of rendering because we've moved all of that work out of the main UI. Definitely cool stuff. Okay, just to sum up, we're really investing a lot in these progressive web apps. We're going to use Universal to make the initial load fast, make it easy to consume and use service workers through our CLI and get your jump started there, and keep a very responsive UI if you're doing heavy lifting in JavaScript. We also, as I mentioned, we want to support this installed mobile realm as well. And there's a couple different options you have. The folks in Angular 1, we haven't had too many options because, like I mentioned, we were tightly coupled to the DOM. We could only render there. We're going to make that better too. But we've already seen that in Angular 2, we've got a couple different places that we can render. One being the DOM, the web worker, and then on the server for Universal. So we can extend this to other places we might like to render. Now, the team we've been working with the longest is Ionic, and they're it's a very popular way to build Cordova-based installable apps for iOS and Android. So this is not really another renderer, but they can take advantage of the web workers and the new speed and memory efficiency in Angular 2. It's going to run much, much better. With NativeScript, however, you can get a completely native look and feel and actually use completely native elements on iOS and Android. So the text fields and the dialog boxes and all of those things, actually native code running at 60 frames per second and all of those nice things. But with Angular still as the core way that we write our applications. We've worked with another team out in Europe to make the same thing happen for React Native. So there's a couple different options, a little bit too much for me to get into today, but there are many ways to install mobile apps. For the Ionic folks, they've actually just released a Windows Universal Platform look and feel icon. So if you want to develop for Windows Phone or even Windows Desktop, here's a great set of widgets that run on Angular 2 already that can work for you. So we have all of these different rendering places that we can go in Angular 2. Well, there's one place left, which is desktop. And so on desktop, there's a couple different ways that you can get there as well. So one, even in Angular 1, you can make use of this thing called the Electron shell. And in Electron, what you do is you get a Chrome web view coupled with Node.js, and they get to talk to each other as part of your app. What this gives you is a way to write real applications just written in what you already know for the web, HTML, CSS, and JavaScript. They've got installers that run on Windows, Mac, and Linux, and give you access to the things that make it feel like a real app, for menus, notifications, all of these kind of good stuff. Auto-update installers, fun stuff. However, if you look at my very simplistic diagram, it looks suspiciously like what I showed for web workers. And so we can do that same trick. In Angular 2, we can move Angular into Node.js and have it run over there. And it has that same benefit that it's fast because it's not on the UI thread. You could do really complex things. If you wanted to write Photoshop now in this environment, why not? Could run on the web and could run on desktop and phones. I think even more powerful, though, is the fact that now that I'm in Node, I actually have direct access to the platform APIs. Many of them are already wrapped for you from Node. You can call out fork system processes, all of these good things. So just from right within the services of my Angular app, now I can call directly to things like platform level authentication, the database, hardware through USB, whatever I wanted to do, without having to go through HTTP and out having this other service layer implemented. Oh, that's super cool. I'm really excited about it. There's a repo here put together by our very own Rob Wormold, who is here at the up in the web development area in the front if you want to chat with him later. And you can get going. Nice little repo. There's another option if you want to go on the Windows Universal path. If I'm only developing for Windows, there's kind of a similar thing here where the architecture, very, very similar to Electron. That diagram I showed on the last page is exactly the same. Develop in HTML and CSS and JavaScript. Runs on Windows and Windows Phone. The difference being they already have wrapped all of the Win32 and .NET APIs. You get immediate access to those. Again, using the Angular core is the way that I build my components and do rendering and dependency injection and all those fun things. And there's a starter repo for this as well. You can go check it out. And I will tweet out these slide decks so you don't have to remember them. Find it later. So this is the entire stack that we're really working a lot on this year to make you guys successful. I hope it's helpful. Here's the list of links. Like I said, I'm going to tweet out the slide deck right afterwards. And you can find me at Bradley Green on Twitter. I'll be around here for a couple, 10 minutes. And then you can find us up front in the area with the rest of the Azure platform folks. Thank you so much.